Imagine stepping into a cosmic journey of no return. The moment you drift too close to a black hole, a phenomenon both magnificent and terrifying occurs: spaghettification. The gravitational tidal forces are so violent that they will literally stretch your body into a continuous stream of subatomic particles. Our universe has always harbored mysteries that defy human imagination, from dark matter and dark energy to Einstein's four-dimensional fabric of spacetime. To easily visualize it, think of a black hole's singularity as a bottomless pit, warped deep into the very geometry of the cosmos. At the absolute edge of this bottomless pit lies an ultimate boundary, the event horizon. Once you cross this point of no return, nothing can ever escape, not even light itself. A black hole is born when an immense, unimaginable amount of matter is crushed into an infinitely small volume. Our Earth creates a shallow warp in the cosmic grid. The Sun, being 333,000 times heavier than Earth, creates a much deeper depression. But when a massive hypergiant star, like BAT 99-98, collapses at the end of its lifespan, its entire mass is crushed into a single point of zero volume and infinite density. This is the singularity. If you were to plunge inside with a spaceship, what would actually happen? To a friend watching from a safe distance, your spaceship would appear to slow down, freezing completely at the edge of the event horizon. The hull would slowly shift to a deep neon red, fade away, and vanish into absolute nothingness. But that is merely an illusion of warped time. In reality, you are still plunging straight toward the center without ever stopping. Now, ask yourself, is a large or a small black hole more dangerous? 99% of people answer wrong. The mind-bending truth is, a supermassive black hole is actually vastly safer than a tiny stellar one. With a galactic giant like Phoenix A, its event horizon lies a staggering 300 billion kilometers away from the center. Because the distance is so immense, the gravitational field right at the horizon is relatively weak. The difference in tidal force between your head and your feet is virtually zero. You can cross that boundary completely unharmed. But what if you encounter a tiny stellar mass black hole? Its event horizon is only a few dozen kilometers wide. The gravity there is 310 billion times stronger than Earth's. The pull on your feet versus your head differs by a factor of 1 trillion. It will rip you into fundamental particles before you even cross the line. If you are fortunate enough to enter a quiet, quiescent black hole, you will witness the greatest movie in creation. The outside universe will fast forward right before your eyes. Stars will ignite and burn out in milliseconds. Hundreds of generations of your descendants will have lived and died in a single second of your time inside. Eventually, the entire cosmos will shrink into a tiny, blinding speck of light above you. And then, every single path inside inevitably locks onto the singularity. Your final fate is still to be crushed into subatomic spaghetti, trapped inside the secrets of gravity forever.